Question 1, we have to identify which gas will diffuse faster. So rate of diffusion of two gases, methane and ethene, were measured. So which gas diffuses faster? So when we work out the mass, because diffusion depends on the temperature and diffusion depends on the mass of the gas as well. So when we take out the mass of CH4, carbon is 12, hydrogen is 1 multiplied by 4, so total mass will be 16. When we find the mass of ethene, C2 means 12 multiplied by 2, 24 plus 4, so it will be 28. So when we compare the rate of diffusion, because CH4 is a lighter gas, the lighter gas will diffuse faster. So what is the reason which gas diffuses faster? That will be methane. And why methane will diffuse faster? Because the molecules of the methane are lighter, so they will move faster. So C will be the right answer. A sample of a dye is investigated by chromatography. The line is drawn across a piece of a chromatography paper, and a spot of a dye is placed on the paper. Which row is correct? So whenever we draw the line, it should always be with pencil. We should not use pen, because the ink in which is used, if an ink pen is used, that ink will also dissolve and it will rise. So we should always use a pencil to draw this line. Origin is always drawn with by using a pencil. And position of the spot. So where we place this spot, like example, this chromatogram, when we place this chromatogram, so it should be below the origin, like the solvent level should be below the origin. Otherwise, when we place this spot here, the spot of a dye, and if we completely submerge this, then instead of spot rising, like example, if a student is doing a chromatography and he completely submerge the origin, then what will be the result of this? The result is, if the spot is completely submerged in the solvent, then this will dissolve, like dye will dissolve, or the spot of a dye will dissolve in a solvent. So we don't want it to dissolve. That's why whenever we place a chromatogram, the origin of the chromatogram should always be above the solvent level. So solvent level should be below and the position or origin should be above, so that the spot of a dye does not dissolve in the solvent. It can rise on the chromatogram or the paper. So what is used to draw the line? So what we use to draw this line, we always use a pencil. So either C can be an answer or D can be answer. Then what should be the position of the spot? Where we should place a spot when we are placing in on a beaker? So the spot should always be above the level of the water. If it is below the level of the water, the spot will dissolve in water instead of rise on the chromatogram. That's why C is the right answer. In question 3, the paper chromatogram below was obtained for four different dyes, four different colors. Which dye is having a RF value of 0.7? Look, there is a simple way to identify. First thing, remember, like example, when we measure this, the formula to calculate the RF value is the distance moved by the spot divided by distance moved by the solvent. So distance moved by spot, you will measure this distance using your ruler scale and measure not till the tip, the center of the spot. So distance moved by the spot divided by distance moved by the solvent. So using your ruler or the scale, you will measure this distance. And using the measurement, you will get the RF value. Or there is also another way just to identify the right answer. Look, example, if the solvent distance from the origin is say 10 centimeter. So if this is 10 centimeter. So what we will do, we will draw a line at the center. So what does it means? It means those spots which are on the line, they will have RF value 0.7, 0.5. Those spots which are below the line, they will have RF value less than 0.5. And those spots which are above this half line, they will have RF value more than 0.5. So we can identify, we can locate the RF value depending on the position. So above the halfway line, because RF value, maximum RF value can be 1. That is the maximum value. So if the spot is above halfway line, it means the RF value will be more than 0.5. Below halfway line, it means the RF value is less than 0.5. And on the halfway line, it means the RF value will be 0.5. So means we are left with only two options. We are left with either A can be an answer or D can be an answer. Why B or C cannot be an answer? Because B is exactly on the halfway line, so B will have RF value 0.5. C is below the halfway line, it means it will have RF value less than 0.5. So what you will do, you can use your ruler scale, just measure from the this distance from the spot, like the origin to the spot. Say this was 8 centimeter. So if I want to calculate the RF value of A, so distance moved by the spot is 8 divided by distance moved by the solvent is 10. So that is 0.8. And same way we'll measure the distance from origin for D. So distance moved by the spot, that is like example say 7 centimeter. So this will write 7 and divided by 10. I'm just using these numbers, but according to your measurement you will get the answer, and the final answer will be D, which is 0.7. So we can work out the RF value by using measurement. Use your ruler scale to measure the distance moved by the spot divided by distance moved by the solvent. You don't have to measure for all of them, because we can identify if it is below the halfway, it will be less than 0.5, and above the halfway, it will be more than 0.5. So we just have to measure for A and D, and we can work out what will be the final answer. In question 4, which statement about the isotopes are correct? What is the definition of isotopes? Isotope means atoms which are having same number of proton but different number of neutron. So which statements are correct? When we check the first statement, they are atoms which have same chemical properties because they have same number of electron in the outermost shell. That's true. Isotopes have same proton and electron, so one is correct. They are atoms which have same number of electrons and neutron but different number of proton. That is wrong. This is not the definition. Isotope have same number of proton and different number of neutron. So they have same number of electron and proton and different number of neutrons. So 1 and 3 matches. That's why B is the right answer. The next one, which element, the table shows an electronic structure of 4 atoms. Which 2 atoms combine to form a covalent? So to form a covalent compound, they should be non-metal, because non-metal can form a covalent compound. So when we check which one is, this is having 1 electron, so it is a metal, 4 electron non-metal, 4 electron non-metal, 7 electron non-metal, and 8 electron non-metal. But because it is having 8 electron, so this will be unreactive non-metal, does not react. So we are left with only option that if X and Y, because metal, this is metal, so metal does not form ionic. So if X reacted with Y, then it will result in a covalent bonding. So if W combined with X, it will be ionic, because metal with W combined with Y, ionic. X combined with Z, so X cannot combine with Z, because Z even it's a non-metal, but it is a unreactive non-metal. So C is the right answer. Which statement describe the attractive force between the molecule? Whenever they use the term molecule, for this question, question 5, the type of the bonding, remember, when metal combined with non-metal, the type of the bonding is ionic. When non-metal combined with another non-metal, the type of the bonding is covalent. That is the idea. So when you look at their electronic structure, if element is having 1, 2 or 3 electron, it means it is a metal. So W is a metal. When you check X, 4 electron, so it is a non-metal. When you check Y, 7 electrons, so it is a non-metal. When you check Z, 8 electron, so it is a non-metal. But because it is having 8 electron, it means it is a group 8 non-metal, and group 8 non-metal does not react. So there is no reaction. So you're left with, when you check option A, W is a metal, X is a non-metal. So when metal combined with non-metal, what kind of bonding they will have? Ionic. W is a metal, Y is a non-metal. So when they combine, ionic. X is a non-metal, Y is a non-metal. So when they combine, covalent. X is non-metal, Z is also non-metal, but they don't react. They don't combine with each other because Z is an unreactive non-metal, so they don't combine. So we are the question is, which compound will form a covalent, which of the combination gives a covalent compound? That's why C is the right answer. Is it clear?
Yes, sir, clear.
In question 6, which statement describe the forces between the molecule? Molecule means whenever they use the term molecule, they're talking about simple covalent. So simple covalent molecule, like example, if I say any simple covalent, it can be carbon dioxide, it can be nitrogen, any molecule can be there. Like carbon dioxide is CO2, and there's another CO2. So when we compare the force between the molecule or simple covalent molecules, what kind of force is this? This is a weak force. That's why simple covalent compounds have low melting and boiling point. So there are strong covalent bonds, that is wrong. There are strong ionic bond, they don't have any ionic bond. They have weak force between the covalently bond molecules. That is true because the between the molecule, like this is one molecule and this is another molecule. So between the molecule, there is a very weak force. Attraction is there, but that is a weak attraction. That's why they have a low melting or boiling point. If you have any covalent compound, it's not about even carbon dioxide. If you have water, H2O, so HONH, and there will be another HONH. So the attraction between the molecule is there because they have electrons, protons, so there is attraction, but that is a very weak force, also known as van der Waals force or London dispersion force. That's a name given to these forces. You don't have to learn that name, you just have to understand the fact that this force is very weak. They don't have lattice simple covalent compound, so that's why C is the right answer. The diagram represent So which diagram represent the general structure of solid Z? Solid Z is a metal because you can see a lattice of a positive ion, regular arrangement of the positive ion and the delocalized electrons. By looking at this structure, you can identify it's a metal. If it was an ionic compound, then how it will appear? It will have a positive and negative ions, and there will be a regular arrangement of the positive and negative ions. One positive, then negative, then positive, then negative, and so on. This is a lattice of ionic compound, which is having regular arrangement of the charges. So which statement, which journal structure, because we identify this is having an arrangement of positive ion, and these are the electrons which can move anywhere, they don't have fixed position. That's why the only option which contain a name of a metal, that is aluminium. So A is the right answer. Iodine is a non-metal. When you check the periodic table, group 7 non-metals. Silicon 4 oxide, it is a giant covalent structure. And sulfur, again, it is a non-metal. But in the question, this is the structure of a metal. Which reaction could take place at anode during electrolysis? At anode is a positive terminal, so negative ions will be attracted. Positive ions cannot be attracted towards the anode. So OH ion can be attracted towards the anode, and chloride ion can be attracted towards anode. Because the negative ions are not attracted towards anode, negative ions are attracted towards cathode. So directly A is the right answer. Because anode is a electrode which is connected with a positive terminal. So whenever it always attract the negative ions. The diagram shows some properties of the substance which may be labeled as uranium. So what is uranium? Uranium 92 and 235. It is not a compound, it is element. That is one thing. And it is used as energy source. By nuclear fission reaction, the heavy nucleus, by the help of neutron, break down into lighter nuclei and release energy. So we carry out a nuclear fission reaction or use as a source of energy. And it is also a radioactive. Radioactive means it emit out harmful radiation which can cause cancer. So it is also radioactive. So which option it matches with? If we select A means it is a compound and use as energy source, but that is wrong. It cannot be a compound. If we select B means it is a compound and radioactive, but it cannot be B because it is not a compound. If we select C, it means it is having all, like it is an energy source, it is a compound and it is radioactive. Energy source and radioactive is correct, but again compound is not correct. So when you select D, it means it is energy source, that is true, and it is also radioactive, emit out harmful radiation. So the common property as the one is radioactive as well as used as energy source. The diagram shows a simple cell. This is a chemical cell. So what happened? How it works? We have zinc electrode and we have copper electrode. So in a chemical cell, when we write the reactivity series, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So we have two elements which we are using, two metals which we are using here. One is zinc, another one is copper. So zinc is more reactive always in a chemical cell because it converts the chemical energy to electrical. So zinc, which is more reactive, it will go inside the solution as a zinc ion. So zinc turn, the more reactive metal react first, it turn into zinc ion, and these electrons, because electrons cannot travel through the solution, so electrons start to move from zinc surface to copper surface. So majority of the electrons will return back to the copper surface. And this electrolyte, normally this electrolyte is acid. So if we have a hydrogen ion in the electrolyte, as acid is there, so this hydrogen ion is attracted towards the copper electrode. Now the question is, which statement about the process occurring when the cell is operation is correct, when cell is working. Copper ions are formed in the solution. Copper ions are not formed, zinc ions are formed. Electron travel through solution. Electron never move through solution. Electron always move through the wire. Electron cannot move through the electrolyte or the solution. The reaction zinc atom changes to zinc ion by loss of electron that occur, that is true. As you can see, zinc is more reactive. So what happens? The zinc atom loses its electron and turn into zinc ion. Zinc ion enter the electrolyte and the electrons which are lost will travel in the circuit. So C is the right answer. The zinc electrode increase in mass, that is also wrong, because if zinc atom is turning into zinc ion, the size, because amount of zinc is start to decrease here, so the size of zinc will not increase, it will decrease. Is it clear, this question? The equation for a reaction is shown. The table energies are given. What is the energy given out? So we have to find the bond breaking energy. So bond breaking energy and bond forming energy, and the energy change, enthalpy change, is equals to bond breaking minus bond forming. So bond breaking, we are breaking hydrogen bond in how many of them? Two of them. Two molecules are there. So H and oxygen is O2. So oxygen triple bonded with oxygen. This is a bond breaking. And bond forming, because two water molecules are formed. One water molecule, H2O, what is the structure of H2O? H, O and H. But because they produce two water molecules, so 2HONH. So how many total OH bonds or HO bonds are there? So when we check, there are 4 OH or HO bonds. So bond breaking, hydrogen is 436. Oxygen, this is also 436. And this is oxygen double bonded with oxygen is 498. This will be the bond breaking energy. We sum this, we'll get the bond breaking energy. So 436 plus 436 plus 498. That is 1370. Then the bond forming, it will be 4 multiplied by OH bond is 464. So that is 464 times 4, that is 1856. Then bond breaking energy 1370 minus 1856. This will give us negative 486 kilojoule per mole. So C is the right answer. So whenever you're calculating the bond in energy change, so you have to find how many bonds you're breaking and how many bonds are formed, and bond breaking minus bond forming will give us energy change. Then the liquid X react with solid Y to form a gas. So whenever a gas is given off, we can measure the speed or the rate of the reaction by either allowing the gas to escape so the mass will decrease, or we collect the gas, measure the volume of a gas, and we can find the speed of the reaction. So the first one, it won't work. Why it won't work? Because there's a cotton wool. So when the gas escapes, some of the gas will escape from the conical flask and some gas will enter. So one will not work. Two will work because when the gas is given off, this gas will escape. So what will happen? The reading on the balance will decrease and we can work out the speed or the rate of reaction by measuring that how much mass has changed or mass decreases with respect to time. For C, it won't work. Why? Because the gas is given off, but that gas does not escape as the presence of a stopper due to the reason of stopper. So the mass will remain constant. Like reading on the balance won't change. When we check for 4, the gas is given off. As the gas is given off, this gas will be collected in a gas syringe. So what will happen? The volume will change and we can sketch a graph for volume and time and work out the rate by finding the slope. So 4 can be used, 2 can be used, and 1 and 3 cannot be used. That's why. So option which include 2 and 4, that is D. So either we allow all the gas to escape or either we collect all the gas, then we can work out the speed or rate of the reaction. Which statement explained why increasing temperature, increasing the rate of a chemical reaction? What is the reason when we increase the temperature, the speed or the rate of the reaction increases? So heat makes a molecule move faster and collide often. That's true. Heat makes a molecule collide with more energy and more likely to react. That's also true. Increasing a temperature lower the activation energy. Activation energy cannot be changed by temperature. It can only be changed by use of catalyst. So catalyst lower the activation energy, not the temperature. So even a reaction we carry out at high temperature or low temperature, but the activation energy, the minimum possible energy for reaction to start, that does not change. So statement 1 and statement 2 are correct, but statement 3 is incorrect. Remember, activation energy can only be lowered by use of the catalyst. This is about the reversible reaction. Steam react with carbon in endothermic reaction. So endothermic reaction means when we draw the energy profile diagram, the reactants will have low energy and the product will have high energy. Which condition of temperature and pressure will give us the largest yield? Yield means amount of the product. So when we write like carbon is there reacting with water, form carbon monoxide and hydrogen. So if we increase the temperature where the balance or equilibrium shift in a reversible reaction, so increasing a temperature, we'll get more product, so equilibrium shifted towards right. But what about pressure? The effect of the pressure, we have to check the number of the particles of gas. This is solid and this is gas. So one particle of a gas in the reactant side. And when we check two particles of the gas in the product side. So remember, for a reversible reaction, whenever we increase the pressure, the balance, the equilibrium always shifted toward the side where less particles of gas are present. So in this example, we have on the left hand side, we have one particle, on the right hand side, we have two. So if we increase the pressure, the equilibrium will shift towards the side where less particles are present, so it will shift backward. And if equilibrium will shift backward, the yield will decrease. So we should not increase the pressure, because if we increase the pressure, the equilibrium shifted towards the left hand side and the yield or amount of product will decrease. So what we should do, we should lower the pressure, we should decrease the pressure, and we should increase the temperature. So temperature should be high and the pressure should be low for a better yield. So B is the right answer for this. Which equation represent the reduction? Reduction means gain of electron. And the charge should also, because reduction refers to gain of electron, one thing, and the charge or the valency should decrease. So when we check the first one, 2 and 3, so that is not a reduction because charge is increasing. 2 and 3, that is not a reduction, charge is increasing. 3 become 2 or 3 become 2, both cases charge is decreasing. But second thing, it should be a gain of electron or take electron. So iron 3 is taking electron and it turned into iron 2. So that's why C is the right answer. But in D, what is meaning of this? It means iron 3 turned into iron 2 by loss of electron, because electron is written on the right hand side. So it means it is a loss. But that is wrong, totally wrong. This is not a loss of electron. This should be a gain of electron. So reduction is a gain of electron, so that the charge should also decrease the overall net charge. Then which statement are the properties of acids? Acid can react with metal. Acid can react with metal oxide, metal carbonate, and metal hydroxide. So acid react with ammonium sulfate, that is totally wrong. That is not the property of acid. This is a property of base. The acid turned red litmus blue. Acid turned blue litmus red. They don't turn a red litmus blue. If there's a blue litmus and we have acid, it will turn to red, but not the red litmus blue. So one is not the property of acid. Two is also not the property of acid. So D is the right answer. Which row describe amphoteric oxide? They can react with acid and alkali both. So react with acid, yes. React with base, yes as well. That's why D is the right answer. So amphoteric oxides, oxide can be acidic, basic, amphoteric and neutral. Amphoteric can react with both acid and alkali. Which substance react with dilute sulfuric acid to form a salt which can be removed by filtration? So we want to produce a salt, sulfuric acid. When it react with barium sulfate, it react with sulfuric acid, so it will give barium sulfate. When you check barium sulfate is insoluble salt. So if it form insoluble salt, what we can do? We can remove by filtration. If it were, when sodium hydroxide reacted with sulfuric acid, it will give sodium sulfate. So sodium sulfate is a soluble salt, so we have to use crystallization. Copper metal does not react with acid, and copper carbonate, when it react with sulfuric acid, it gives copper sulfate, which is also a soluble salt, so it will be removed by evaporation or crystallization. So aqueous barium chloride, why aqueous barium chloride? It will give barium sulfate, and barium sulfate is an insoluble salt, and insoluble salt can only be removed by filtration.